Hello and welcome to this edition of Group Talk, Rapid Application Testing, with our host, Peter Presnell, Senior Software Engineer at GBS. Without further ado, let's get started.
G'day everyone, my name is Peter Presnell, and as Dawn mentioned, I work at GBS as a software engineer. I currently head one of the QA teams working with the transformer technology. So this presentation I have given several times before. It was given at IAMLUG, the North American Lotus User Group in St. Louis. Last year it was also given at AUSLUG, the Australian Lotus User Group, in Sydney last year, and I also gave this presentation at LotusSphere in Orlando at the beginning of this year. So those of you that attended this session, this will be a repeat. So unless you specifically wanted to go over the material a second time to pick up some of the stuff that you missed, there will not be a lot of new material in this presentation when compared with those previous presentations. So what I'm going to be doing today is sharing with you some of my experiences that I've learnt since taking on a QA role here with GBS. I have been working with Lotus Notes for quite some time. I think it's 17 years of Lotus Notes experience. Most of that has been as a developer, although I have worked doing desktop support for Lotus Notes and also worked as a Domino administrator. So over that time I've gotten to learn a lot about the Notes technology, and since joining GBS my primary role has been to put together a QA program for testing Notes applications, an area that I have found has often been neglected in the Notes community, which is one of the reasons why I felt compelled to put together this presentation to start to spread the word to people, those of you that either participate as testers of applications or develop applications and would like to think that your applications are well tested before you pass them on to your customer for the ultimate testing. So for those of you that are interested, I am on many of the social medias. There's the information if you want to connect with me or read the material that I put out into the social world. This presentation is recorded and will be available for those of you later on want to come back and pick up the contact information. So the agenda for today, this is a 1-hour session, so I'm going to try and get through the presentation in 45 to 50 minutes, all going well, so that we can leave a little bit of time towards the end for those of you that have questions on this particular topic. I'm going to start off with some general introduction to some of the concepts of testing that I find particularly important for the work that I do. I'm then going to look at some of the development methodologies, specifically the ones that are more common with Notes application development, before moving into a series of layers of testing that can be applied to applications. Then briefly cover some information about how you can design applications to be testable, and finally we'll conclude with some material related to the automation of testing. So let's get started with some general information about testing. First of all, my title on my business cards is Effer of the Ineffable. It took me a while to figure out what that was when my manager Nathan Freeman first gave that title to me. So I looked it up in the dictionary and I found that the definition of ineffable is incapable of being expressed or described in words, or not to be spoken because of its sacredness. And in many ways this is a very close match to the art of QA, because if you take one well-known quote from James Bark, testing is an infinite process of comparing the invisible to the ambiguous in order to avoid the unthinkable happening to the anonymous. Now normally when I give this presentation I'm in a room so I can get a show of hands. So I normally ask the question, how many people participating in the presentation consider themselves to be testers? And if this crowd is has a similar profile to those that have attended my presentations before, there'd be a small showing of hands in the room, but certainly not everyone would be raising their hands at this particular point in time. Bill Gates had an interesting perspective on testing, in which he basically said Microsoft is more of a testing organization than a software organization because of the fact that they have nearly as many people testing their software as they do developing their software, and half the time spent by those people developing software is testing the software in the first place. So when you add it all up, there is an awful lot of time spent within most software departments or organizations actually testing the software that is being written, and often there is more time being spent than there is actually writing the code, which makes it strange that after all this time we do not focus an awful lot on the testing of software. If you were to attend Lotus user groups meetings or LotusSphere, you would find most of the sessions are actually out there designed to give you skills, techniques and tips and so forth about how to write good software, but not very much is actually shared on how you test that software to make sure that it is meeting the quality standards that you aspire to. So normally I would then say, well, having considered that, does anyone want to change their position as to whether there are testers? And I'd like to guess, without knowing the profile of anyone on this call, that more than likely everyone out on this call is a tester in some way, shape or form. You do get involved in evaluating the quality of the applications that are being built in your organization and providing feedback of where you see gaps between what you believe the application should be doing and what it actually does at this particular point in time. So largely, as I said, we should all consider ourselves testers no matter what role it is that we play within a software development organization. Even if your role is that of the consumer of the application, you are the ultimate tester of it, because once the software is delivered to you, part of what you do is you look for things that are not working well, and then you have a responsibility of reporting those back to those that wrote the code in the first place. So there's important aspects about testing. First of all, we need to understand that testing is designed to prove the presence of defects, not to prove their absence. So it doesn't matter how good you are as a QA person or as a testing person, you can never prove that a piece of software doesn't have any bugs. That is simply not a possible assertion to make. No amount of time, no amount of effort is ever going to prove that a piece of code is perfect. What you can do is indicate that you've not been able to find any major issues with a piece of software given a certain amount of time or effort that is invested into testing the software. But you should never take the position that there are no bugs in the code. Rather, the position is, I have been unable to find any bugs in the code at this time. Okay. It's also important when testing software that you focus on trying to discover the unexpected, because that's far more important than merely confirming the known. By that, writing a set of test cases for common operations that you know are going to work doesn't do an awful lot for your organization. It might produce a set of numbers that might look good in a presentation, but the job of a QA or testing person is to try and find the things that are not working, not to confirm the things that are already working. So when it comes down to testing applications, you often do not have the resources or the time that you would like to have to test any one piece of software. So the suggestion is that you try and focus your time more on getting to the things that are unexpected than merely trying to run a set of scripts that you are pretty certain are going to pass each and every time that you run them. You're just simply not going to get the return on investment for all that time and effort. So why do we invest in having QA departments or having developers testing the software? There's a range of numbers out there. You can use whatever numbers you want, but they do tend to follow this one common pattern, and that is the later in the cycle that you locate a defect, the more expensive it is for your organization to find and fix them. So as an example, a typical number would be that if you found a defect during the requirements stage, because you haven't even gotten to the point of actually writing any code yet, the typical cost of fixing that would be something of the order of $250, whereas if you found a bug after it had been released and it was a bug that is being found by a customer, then the order of magnitude is something like 20 times more expensive to fix a defect when it is a customer that is actually reporting the defect in the software. So clearly, because of that cost factor, we want to try and find those defects as early as possible in the cycle so that we can drive down the cost of actually remediating, because you've got to remember that when you're testing software, there's two costs. There's the cost of you finding the problems, then there's the cost of somebody else fixing the problem. So the total cost of the quality is taken by adding those two numbers up. The Pareto principle, or often known as the 80-20 rule, is very common in the QA world. Largely speaking, you can take it that almost that 20% of the effort will deliver 80% of the results on anything that you do. So when you're constrained with resources, you do not have the time that you want, then clearly if you can focus your effort on the areas that are going to generate the greatest return, you'll get a much greater return on that investment. Because it's almost certainly going to follow that the next test will probably cost you more than the one that you've just completed. So you're going to get diminishing returns. It should also be borne in mind that some defects cost more to find than not to find. So leave them in there. Okay? Don't approach it from the point of view that you need to find every single defect that's in the software, because you'll end up spending an inordinate amount of money. And the value to the organization of actually finding and fixing some defects is simply not there. You do not get a return on the investment. It's cost you more to actually create the test, run the test repeatedly, then get the test fixed, and it may be a path in the code that is never followed within an application. Of course, you can never accurately predict what parts of the code are going to be used, so you have to use a degree of judgment, but if the better you understand the applications, the more likely it is that you can judge which parts of the application require the greater focus. It also holds true that automated tests are usually faster than manual testing, but it is not always proven that they are cheaper than manual tests. So whilst I'm a great proponent for automated testing, I do not approach it from the point of view that I need to have all my tests automated. There's a certain number of tests that are probably far more cost efficient to be run as manual tests, because the cost associated with automating those tests is so high that it will never get the return apart from some ego of being able to say I have all of my tests automated. There is no true value in having every test within your organization automated. It also holds true, as I've mentioned several times before, that some tests are better predictors than others. So the art of a tester or the art of a QA person is to actually judge which of those tests that are going to be the best predictors of the health of the application. There's usually a small subset of tests that you run that if one or more of those fail, that's a good indicator that there are other parts of the application that are not going to work well. And so those are the sort of tests that you particularly want to focus on when you're testing your applications. So at this stage, I would only ask the audience whether or not these statements would apply to the organizations that they represent. I'm going to summarize the responses that I've typically gotten. Is that if I was to say our company's IBM Lotus Notes applications are always well documented, I would suggest there would be almost nobody putting their hands up to say this is a true statement. It certainly isn't true of any of the organizations where I've worked doing Lotus Notes over the years. Likewise, all our Notes applications have formal test plans. If there is an organization out there that has formal test plans for all their Notes applications, I'd like to know about it. I'd like to use them as a case study for something, because I have not seen an organization come even close. I've worked with organizations that have had something like 80,000 applications. Most organizations don't even understand what most of their applications do, much less have formal test plans in place to establish how they test those applications. So again, I don't think there are many organizations that can claim this to be a true statement. Most of our Notes applications have formal test plans. I think there are a couple of organizations out there, probably in the financial sector or heavily regulated industry, where this may be true, that people have taken the time and effort to document formal test plans for their organizations. Many organizations would probably fit into this category, where they could claim some of their Notes applications have formal test plans, I think. And I put the I think in there because often people are not sure where those test plans are. The developer who developed the application originally, you may recall they did develop a test plan, but you're not sure where that is anymore. So when it comes time to testing the application, even though a formal test plan does exist, it may not be accessible to those that are actually now having to do the testing. I've also worked in quite a few organizations where it's true that none of our Notes applications have formal test plans. This is not a judgment. This is just an observation. This is typical. This is the way that most Notes applications are developed. A lot of Notes applications have been developed outside of IT departments, outside of formal SDLCs. They have little or no documentation. They are unlikely to have formal test plans in place. So we just need to recognize this is a likely scenario that if you're given a new application to work with, to do enhancements for or to fix problems for, you are more than likely not going to be surprised if this application does not have a formal test plan. Which leads to moments like this, such as who wrote this code. So you're looking at the code, you can't understand it. In many cases, Notes code is written by people who have not been trained in programming, so some of the code can look fairly strange. We will often have situations where we're migrating to a new release. You might be doing a major upgrade from, say, Notes 6.5 to Notes 8. I've worked with several organizations that have done the jump from one or two major releases and suddenly felt it would be a good idea to test all those applications before they migrated, but they weren't quite sure how they would approach it because there were little documentation and almost no test plans in existence. You may be involved with migrating applications to XPages. So when you migrate them to XPages, one of the things you're going to ask yourself is, does this application now work or continue to work the same way it did before? Well, in the absence of a formal test plan, it's going to be very difficult to actually establish that. Increasingly, people are being asked to add mobile interfaces to these applications. Again, in testing those mobile interfaces, you have to answer the question, does this application continue to work the same way it does on the web client? Likewise, we often can do server consolidation. IBM's invested an awful lot over the recent years in driving down the total cost of ownership of Domino servers, and this often leads to a reduction in the number of physical servers that are needed to support a Notes infrastructure. And as applications get moved from one server to another, those applications need to be tested because many of those applications will have server names hard-coded into the applications themselves, and unless you test them as part of that migration, things are going to go wrong at the worst possible time. So with all of those situations, the question that you're often asked is, does it still do what it did before? Right, and that is the $64,000 question. How do we verify that this having done some change to an application, how do we verify what it has done before, especially when we didn't write the application before, especially when there is little documentation about what the application does, and if there is no formal test plan in place for you to verify whether the application continues to work the way it's done before. I've certainly found myself in that situation many times with a great many applications. So the solution to this is when you find yourself in a situation where you don't have a test plan but some significant change is being made to that application, is that you write one set of tests. And then you run those tests against the original application, and then you run that same set of tests against the changed application, and you compare the results. You don't need to judge what the result should have been. You just need to establish whether the result is the same. So if you follow an operation before and it does X, and it continues to do X, rather than trying to establish whether X is the right answer, you just accept that if it's giving you the same result as it did the previous time, then that will be acceptable in terms of the work that you're currently doing. So let's look at some of the methodologies now that we'll often encounter when developing applications, because they do have some impact on our approaches to testing applications. The first one I want to talk about is rapid application development. It's rapid application development, or RAD, is largely a term misused within the Notes community. It's sometimes used to apply to the speed with which an application is developed. It is actually a formal methodology. You can Google it on the internet and you can find the definitions of replication methodology. It often is quite fast in development. but it basically follows a very similar pattern to, for those of you that live in the US and are familiar with a series of ads that Verizon, I think, used to run. This guy would walk around the North America with his cell phone saying, "Can you hear me now?" And then he'd take a few more steps and say the same thing, "Can you hear me now?" Well, rapid application development basically follows this approach. What you will start off with is listening to the customer, or you might actually be the person for whom the application is developed, and you'll write some code. And then you show it back to that person and you say, is this what you want? And then you'll get some feedback from them, and they'll say, no, can you add this, change this, and you go away, make those changes, bring it back, and ask that same question, is this what you want? And then they'll say, no, can you just add one more thing here and take this thing out? I decided we don't really need it. You go away and make those changes. Eventually, they will accept that what you're showing them is what they want, and then it becomes a production application. In many cases, it'll become a production application, and this conversation will continue endlessly. Your customer will be forever saying, oh, can you just add this and subtract this and make this change? And so the application evolves over a period of time in a series of small steps. This is what we call rapid application development, and in many ways rapid application testing follows a very similar approach. The other methodology that is becoming increasingly common within notes development is agile methodologies. We use agile methodology here at GBS. The one that we use is Scrum, and the tool that we use is a tool called Rally. Fundamentally, this involves breaking development down into a series of iterations. In Scrum, it's called sprints. We, for instance, work on a 3-week sprint. So we define a list of things that are going to be done. The time frame is fixed, and then we work to a fixed time frame to get as much into that release as possible. And if we can't get things in, we pull them and put them into the following sprint. It makes life easier to plan because you have fixed time periods, and so consequently you don't have to readjust project plans to reflect deadlines that are being changed on a daily basis. Okay, another one that I quite like is called paired programming, which is taken from extreme programming, which is where two people actually sit together and one person writes the code and the other person observes, and then typically after an hour or two they would swap over and the other person observes. I have worked with people who have done extreme programming. I've not done it myself, but the people who have done it tell me that it is actually possible to produce code at the same rate this way as it is with having people just work one person on each assignment. The significant advantage of extreme programming is that it's been found to significantly reduce the defect rate in the software that is written, which is probably no surprise because as the code is being written, we already have a pseudo QA person sitting in the co-pilot seat watching the code that's being developed, and they will challenge and question the code that's being written if they think it's different to their interpretation about how the solution is being written. Another methodology that I particularly favor is one called test-driven development. This is also part of the extreme programming mantra. In this, you define your criteria for success before you start writing the solution. The other way I like to express this is ready, aim, fire, rather than ready, fire, aim. So generally speaking, rather than writing requirements, you write test cases and you give those to your developers. The developer's job is to write enough code to pass those tests. Once they've got all those tests passing, they can stop and move on. Why this is particularly effective is that developers will often be too pedantic in the solutions that they provide, and they write elaborate solutions to problems that solve situations or scenarios that are not being called for to be solved, which would be test cases that don't exist. So this often leads to programmers moving on much faster from one task to another because they know as soon as they've got all those test cases passes, they don't have to second guess how else this application might be tested, and then provide solutions for all those particular edge cases that just may never happen. Okay, so the third section of this presentation I now want to cover is some of the layers of testing. So the first layer is functional testing. This is where you test to make sure that applications work because each of the parts do their job. So you would break the application down into functional pieces. You can look at this from a system perspective or from a user perspective. And either developers will tend to focus on the system and test individual modules of code to make sure that every method and class or event in Notes terminology is working, and assume that if each individual piece is working, there's a higher chance that the entire application is going to work. For QA, you would tend to break the application down into functional requirements and have different ways of verifying each specific requirement is being tested as a standalone unit. Once we've developed the individual pieces, we could then move on to integration testing. This is where we validate that the little bits come together to make a big picture working. For this, you would tend to take things more at a transaction level. So as an example, if you're building a travel application, you may want to take a travel request and you would take it all the way through a workflow that is being designed to make sure that it gets from the beginning to the end. And you would have various test cases written for various scenarios that might exist. You know, the first one might be a simple case of an employee submits a travel request and then it's approved by the manager and it goes back. The second one may be where they submit a request and then it's rejected by the manager, and then a third one would be submitted, rejected, and then resubmitted and then approved. So you would actually make sure that in each of those situations you get the exact result that you're wanting. The next one is smoke testing. It's a little known fact that smoke testing gets its name because this is where you get to find out what your developers have been smoking when they were writing their code. These largely are the tests that you must always perform each and every time you're contemplating making a change to an application that's going to be released to the customer. So largely speaking, you need to look at it from the point of view, if I'm about to release a piece of software, what are the things that could go wrong in the application that would cause me to make a decision not to release that application to the customer? What are the fundamental things that are so important that I simply can't allow to break? As much as we might like to think that we don't give customers software that has 0 bugs, and remember that we can never prove there are 0, we will be giving them almost certainly software that has bugs in it, just that we can't find them, and we're going to hope the customer doesn't find them. It is rare, or if not rare, it is expensive to actually always deliver code that is perceived to have little or no known defects. So sometimes you'll make decisions, and certainly IBM does, to release software to its customer where there are known issues. But there will be certain issues which are sacrosanct and must always be addressed before the software is released. So what you would do is you would isolate out those particular tests and put them into a group called smoke tests. And then you would always run them first in your test cycle, so that if there are any problems with these smoke tests, you can start to get a response immediately. In some operations, the failure of any one smoke test is enough to cause the QA process to stop and for the code to pass back to the developers to fix before they will continue on to do any more detailed testing of that release candidate. System testing is the next layer that you would potentially add after smoke testing. This is where you look at what did we add to the application, what did we change in the application, and what did we fix in the application. Because once you've verified that there are no important issues going astray, what you then want to do is specifically test and look for problems in the things that we deliberately tried to change in that application. So we put that in as a second layer that is known as system testing. And so for this, you need to have an understanding about what are the things that the development team have been working on with this application, or if you are the developer and the tester, you would know, well, what are the things I've just changed, and therefore what are the things that I need to specifically test to make sure that they're doing what I've been asked to do. Once we've run the system tests, the third layer of testing that we can run is regression testing. This is where we go back over all the other parts of the code that we didn't think we made a change to verify whether or not we broke something inadvertently as a result of implementing those enhancements and fixes to the application. This is the often the larger, more expensive part of the testing cycle, because once you've got over the initial release, you will have a large number of test cases potentially sitting there to be run as regression testing. That's why you would leave this to be the third element, because depending upon how much time you have available to do testing, your priority should always be do the smoke test first. Do I have any more time? Then do the system test. Do I still have more time? Then do the regression test. And however much regression testing can be done will often be based upon the acceptance rate for risk for that application or for the organization as a whole. Another layer of testing that is often neglected is performance testing. We as developers would typically test our applications on our local workstation because we get better performance, we can get through the work an awful lot faster, but all we've really proven is that the application works okay on my local workstation. This is invariably not the environment your users are going to be using an application. In many cases, applications will have 1,000+ users, and not only do we have a large number of users, that application will be hosted on a server which has maybe 1,000 other applications on it. So you have no guarantee exactly how much of the server's time is going to be focused to servicing each and every one of those users of the application. So when it is important that performance characteristics are measured, you do need to put into place some form of performance testing to verify under load the application is going to perform with an acceptable response level. Mining defects. It has been my observation code is often a repeat offender. Okay, so once a bug has been found to exist within a piece of code, it is a high probability that that piece of code may go wrong again in a later release. So what I try to do as a general principle is every time I have a defect reported to me, I try to turn that into a test case. Okay, that way the next time I'm contemplating to do a release, I will make sure that this same defect does not reoccur, because customers absolutely hate having to solve the same problem more than once. They usually do not like having to report a problem in the first place, but if they report a problem and you tell them it's fixed, and then later on, a couple of months later, they have to come back and say that they're reporting that they found the exact same issue. That is often when you start to lose trust from your customers in your capabilities in developing software. So there's another reason for wanting to make sure that once a defect has been reported, you have some test case in place that's going to verify that that solution is continuing to stick. CRUD testing. For those of you that are not familiar with the term, CRUD refers to create, read, update, and delete. The vast majority of Notes applications are designed to allow users to create, read, update, and delete documents of some particular type. So therefore, whenever you wanting to test an application, it's often a good idea to take the application and look at the basic forms or objects that exist within the application. Simple applications such as a travel request application might just have one form, one document type, which is a travel request. So you only need to verify your ability to create, read, update, and delete a travel request. Other applications can be more complicated, can have 5, 10, some 20 or 50 different forms or objects. And so what you would need to do with CRUD testing is basically write some test scripts that would verify that it's possible to create, read, update, and delete each and every one of those document types that exist within your application. So in terms of finding out what you need to test, the answer is out there, and the answer is in the form of DXL. For those of you that are writing notes programs that are not familiar, when the Eclipse editor for Domino Designer became available, there is an option in there to actually view, or even if you're really risk-averse, edit the application code in the form of DXL, which is IBM's implementation of XML for Notes Domino applications. If you were to look at the DXL of a typical Notes application, you would see something like this, where there would be a form tag created for each and every form that exists within the application. What you could do is write a piece of code that can actually parse the DXL of your application and give you a comprehensive list of all the forms, for instance, that exist within the application, and then generate a list of the test cases. So for every form, at the very minimum, you want to have, can I create, can I update, can I read, can I delete a document using, in this case, a smoke test 1 form. The next layer of, that we could look at is UI components, which is where we would look at every component that exists in an application to make sure it behaves the way it should. So when I'm talking about components, I'm talking about all the input controls, actions, buttons, all the things that you can click that normally have some form of event associated with them to verify that that the application is working. So how do you find all those pieces of code? Well, again, you can use the DXL, or in this case, we're looking at an XPage example. The XSP markup code that's used with XPages is very similar in style to DXL for Notes applications. So consider these two as being comparable. With XPage development, it's exposed to you in a source tab when you're editing the application. With the Notes application, it's not normally exposed to you. You have to use the menu option to edit the DXL within Designer to actually see it in this XML format. But again, you could write code that actually would parse your application and find all those components and give you a list of all the components that exist within an application, that which when you click on them or do some other event such as drag or drop and so forth, will trigger some form of code, because potentially they are the points that you need to test in your application. Each and every one of those is something that needs to be verified. UI state is where we change the look and feel of the application based upon the content of documents at any point in time. In Notes Classic, this is what we refer to as hide when formula. Within XPages, it's either the visible or rendered options. There's slight differences between those two, but largely what we're doing is controlling what can be seen by the application based upon its state. So what we need to do is we need to find every combination of hide when formula that exists within the application and then test the documents using each and every one of those combinations to verify that we're getting the results that we're expecting. So again, the DXL or XSP code is going to help you to find where all the hide when formula are, so you could actually create a piece of code that would spit these all out for you rather than having to click around in Designer on all the possible places you could think of where code could be hidden. So this is what it's going to look like within Notes Classic. We have this capability to hide an entire paragraph from the Notes web or mobile interfaces, and then there's also an event known as a hide when event, into which hide when formula can be actually assigned to a paragraph of text, in this case on a form. So they're the sort of the key things that you would be looking for if you're wanting to automate the process for identifying. The next one is the event model. What we need to do is identify what are all the events that are in the application and ensure that they work, doing what they're supposed to do, that they fire at the correct time, and that they're executing in the correct sequence. This is especially true when you're migrating applications from Notes Classic to XPages, because the event models are different and there can be some significant consequences of different events firing in a different order when you go from one model to the other. So again, if you want to identify what those events are, you would look at the DXL and you'd be looking for something, a tag that says event equals, and that's going to give you information about what are all the events that have been programmed to do some form of business logic within your application. It's important with event logging that event model testing that you put into place potentially some form of logging. This is especially true with XPages because there is not a native debugger for XPage code. So if you're trying to figure out what's going on with your event, it is often a good idea to have your code be able to log what it's doing, so that if the event is not working, you have some way of identifying where in the code it may possibly not be doing what you want. And you possibly also then want to have some trigger for turning that logging off or on, because you don't want to, certainly your administrators are not going to want you filling up the Domino console with an awful lot of diagnostics for applications. It's something you more want to turn on when you're testing your application before release or when diagnosing a problem that's been reported from a customer. For understanding event model logic, there is various software out there that will flowchart LotusScript code, for instance. One of them is avosto.com. It's an excellent program because when you can visually see the program logic of the event, all those decision boxes are different paths that you potentially need to test. And so that will help you to define what the test cases are that you need to create in order to verify that, that a particular event is working as expected. Styling requirements are a matter of need, design is a matter of principle, but style is a matter of taste. So often it is very difficult to put into place test cases for styling because it's very much comes down to individual people, and depending upon who you'll talk to, they'll give you different answers as to how the application should look and feel. But at the very least, you should be mindful of how to establish where formatting has been placed in your application. In particular, these color codes that get generated in the DXL, it is often a good idea to generate a color palette either for your organization as a whole or certainly for the application, because when developers have built applications, they will pick a slightly different shade of green on one form to another, and this is a way for you to pick up where inconsistent colors have been applied on different design elements or components of design elements, so that you can bring them into line and have them all using at least a consistent palette. In terms of workflow is an important part of Notes applications, so therefore workflow testing can be another layer that you want to add, in which case you need to define the workflow in terms of the states and transitions. There's various models. You can use UML or Visio tools to represent the workflow, and what you would then do is, as some form of integration testing, you would actually make sure that all the paths, the transitions that are allowed to exist are actually tested as part of the test plan for your application. So let's now move on to designing testable applications. So they're all the layers. I should go back. Basically, rapid application testing involves taking those layers and choosing which ones you want to apply to each and every one of your applications. It's not about having a comprehensive plan for each and every application, but rather picking the ones that you consider are most relevant and then just doing enough testing to meet the threshold of need that exists for each and every one of those applications. So you're going to try and you keep adding tests until you've got enough tests in place to meet that threshold. So starting with 0, you add a couple of tests. Do we have enough tests? No, write some more. Do we have enough tests? No, write some more. And you'll pick from the different modules different types of tests that you want to have to give you a good cross-section of testing for the application that's going to give you the best chance of finding those unexpected things that are existing within the application. So let's now quickly look at designing testable applications. It's certainly true that LotusScript is easier to unit test than at formula. Object-oriented LotusScript is much easier to test than procedural LotusScript. Implementing an MVP MVC model is easy to unit test than standard code. If you don't know what that is, certainly search for that term on the internet. There are certain design patterns that involve abstracting the business layer from the presentation layer that will help in getting testable code. Java is certainly easy to unit test than server-sided JavaScript. And it's always true that my code is easier to test than yours. And by that I mean if you're the person who wrote the code, you're going to find it much easier to test your application. So it is also much easier for you to put into place the test plan than to not write anything at all, and then the person that then has to come along at a later stage and gets asked to make changes to the application. If they have to test the application, it is almost certainly going to be the case that they will not be able to test the application anywhere near as well as you do, because they do not have the same inherent knowledge about that application. So the best time to write the test plans for an application is when the application is first written. It is often a thing that's put off to for another day, which is why I like test-driven development, because with test-driven development you can't start writing the code until you've written the test cases. That way you ensure that you've got a test plan in place to verify the quality of your application before the application itself is actually written. In terms of building testable applications, no hard-coded server names, no hard-coded mail recipients. In fact, no hard-coded anything, because every time you hard-code something, that increases the probability it's going to break when your organization changes. And almost every organization does change. Every organization has personnel changes, mail addresses change, people get married, their last names change. A lot of things happen, and they're predictable. So we should write code understanding that our organization is going to change. We should also add debug parameters to code. Add the ability to allow a tester to get the information they need to understand what's going on within your program. This is best designed when the application code is written in the first place. So put the testing code in place as part of that initial development. Don't add it as something later on because you've now got a bug, because it is often much harder to put into place an effective debugging framework if it's not integrated into the application from the very beginning. This ties into design your code to be testable. When you write code as a developer, think about how would you test this application. Are there certain subtle changes I can make to my application that would help to make it a little more testable? Document environmental dependencies and constraints. The biggest issue we often have when we try to take applications that we get from our customers and test them is just to understand, does this database need something else for it to work? Does it need certain keyword documents or profile documents existing with certain data in it for it to work? These are the things that are probably more important than anything else to document, because it is often difficult when you take an application and move it onto another server and you're not allowed to have production data, for instance, in the test environment, to get the application to the point where it can be tested, because it wants to talk to 3 other external notes databases, and it's assuming that a particular username exists in the name and address book, which may not exist within your QA environment. And also consider providing logging options, as I mentioned before, especially with the events, so that you have some way of following what the code is doing at that particular point. So now briefly I want to go through automation. Automation allows the same test to be run many times for little additional cost. The tool that we use is a tool called Selenium, which is for web testing. One of the great things about XPages is that XPage applications are web applications, which means that you can use most of the testing tools that have been developed for testing web applications. Notes applications are a lot harder to test because there is not as many testing tools out there. There are a couple, but they are much harder to find and they don't offer the same range of options that you will find when it comes to web testing. So if you're building XPage applications, you're going to find it an awful lot easier to test and to automate. More time and effort should go into test planning than test execution. To do rapid application testing requires a significant investment in automation. Test automation scripts are simply code, so you as a programmer can automate the process for generating automated scripts if you so choose. Firefox has a great tool called Firebug. Chrome has developer tools, and Safari has Web Inspector. IE, on the other hand, has great marketing. It doesn't have great testing tools. So even if you're a shop that uses Internet Explorer, consider testing your applications using a browser other than IE, because you're probably going to get to the problem an awful lot faster. If you're looking for memory leaks, there is a product called YourKit, which is excellent for finding and detecting memory leaks as each and every time you run an application. Does the memory consumption go up? Medusa is a tool that has been developed by a couple of the people here at GBS, Tim Tripconi and Nathan Freeman. You'll find that on OpenNTF. And just remember, despite everything that I've said, sometimes it pays to stay in bed on Monday rather than spend the rest of the week debugging Monday's code. So with that, I'm not sure what's going on out there, whether you're all looking like this at the moment, but I will see if there are any questions.
Thanks, Peter. We do have a handful of questions in the queue that I'll read off to you, and I'm going to encourage everyone while we're doing that to enter any additional questions that you might have before we let Peter go. The first question I have, I think you covered a lot in the presentation, but it came through early on, was can you describe the tools used for application testing? So just to let everyone know, the presentation that Peter gave will be available for download later, but I'll let you answer.
Sure. First of all, rapid application testing is as much a process. So with rapid application testing, what we're saying is rather than trying to have all the tests you could possibly think of and get them written, which could take an awful long period of time, start with nothing and work your way to where you want to be. Do it in an iterative process, just like you would do rapid application development. Write a few tests. Write the most important ones. Think about what are the tests that you need to have and simply create test cases. Now, as to which tool you use, you can start out with something simple. You can start out with an Excel spreadsheet or a Symphony spreadsheet. You could write your own notes application to store them, or you could use some of the more advanced tools such as Mercury Quality Center and Test Director and so forth, and the Rational Suite for storing test cases. It doesn't really matter. What we're saying here is the typical approach is to try and do it all up front and write all the test cases to plan out the complete matrix of what's needed and do it all. That often is what puts most people off from starting in the first place. So what we're saying here is try and figure out so you can start out with just what are the things that are breaking. Every time something breaks, write a test case for it. Likewise, get the smoke tests identified early on. What are the things that are vital to this application? At least get smoke tests for each of your applications so that you're testing the things that are critical that would stop the application from working. So in terms of specific tools, we're actually developing our own tools at the moment to do this, which involves parsing the DXL. There's a lot that can be done by acquiring the skills necessary to read that DXL so that it can generate lists for you of what's in the application, because what is very slow is the time that if you have to open up each application in Designer, then open up every form and every view and try and click on every button and look at all the events to actually see where the code is. If you can get to the point where you have a tool that you can run against your application, then you're going to get the answers that you want an awful lot faster. So hopefully I've answered that question.
Okay, the next question is it possible to implement RAT in a manual test environment?
Absolutely. At the moment, we probably doing about 80% of our testing manually, at least the testing that we rely on. We've got a lot of work going on in automating the testing, but it's more important when you're doing manual testing to have RAT, because manual testing is expensive to run. So what you don't want to be doing is running a lot of unnecessary tests. What you want, this is where the 80-20 rule becomes very delivering bottom line value to your organization, because if you have to have someone manually executing a test each and every time, then cutting down the number of tests that you need to run is an important thing. So it's not about, as I said, don't spend all your time manually proving the things that you know are going to work. Focus on running just those tests which you think have got the highest probability of failing. The other thing I would mention is that even where we have automated testing, we always run our testing manually at least once or twice before we run it automated. That way we have a human running through the test script, picking up any anomalies in the test script before it is converted into code.
Okay. Next question is, it's kind of a daunting process. How do you know where to get started?
Good point. I mean, that was me on day one. So, as I say, don't be daunted by the sheer magnitude of what can be done with testing. I've presented today a whole number of layers, different types of testing you can do. Don't worry about, I mean, understand the types of testing that can be done, but just pick a starting point. Make a start. If you if you set yourself a goal, I don't know what it could be. It could be like to have 5 test cases. Every time you have a new release of an application, you set yourself a goal of writing at least 5 test cases. And they don't have to be overly elaborate. If you know the application well and you're running the application, you only need to write a one-line description. You don't need to provide a comprehensive test script. Okay? That's always good when you have other people running test scripts. But often I, as a developer, just need a list of things that I need to test. The whole point is to have it repeatable. So if you write them down so that every time you test the application, you're running the same tests. You're not just running what's called exploratory or unscripted testing every time, in which case you get different results depending upon who ran it on which day. What we're talking about here is having a discipline where you record what is. See, a test plan can be something as simple as a Word document or a Symphony document into which you've got a bullet list of 10 things you test with this application. So as I say, to get started, just write down 5 things that you want to test. And then over time, just improve it. Just do it on an iterative process. Don't set your goals that you haven't gotten anywhere until you've got a comprehensive test plan in place that's got 500 tests that test all those aspects, and we've got it all automated. You don't need to be there. Anything is better than nothing. So just start small and then increment your way up. Very good question.
Okay, next question is, can a complex application that's designed to work on the web using LotusScript be tested using RAT?
I'm not. Yes, we use it. I mean, because it's largely the methodology is largely technology agnostic. So whilst I've targeting this at a Notes audience, you could apply it to anything. So whether or not there's LotusScript there, whether or not there's web there, doesn't really matter. The whole concept is start small and then incrementally add to your test suite. What the tests are is going to vary from application to application, but the general principle is that you try and identify the things most likely to fail in your application that are worth knowing about. And it's important to worth knowing about. Whether or not the wrong shade of green is used on one form or another is probably not the first test I'm going to write for an application. The first test I'm probably going to write is something like a CRUD test for create. If I cannot create documents in my application is going to die, right? Creating is more important than deleting. Reading is important and editing is important. So I would take the major forms and have verification that I can create, edit, and update my major forms. I may not have test cases for some of the administration forms that exist in an application until much later on, several years down the path. I would start off with those important things that are most likely to yield results. Look for the events that have got complicated formula in them. The ones that got the most lines of LotusScript. Create a test script or 2 for those very complicated things, because they are probably the things most likely to go wrong, and especially if it's got something like salary or approve or decline. They're major events in the life cycle of your application. They are the events. Just write some scripts that test those things. It doesn't matter if everything else is untested. Start with something and then improve.
Okay, the next question I have out there is, are there any tools available that would allow you to parse the DXL? I think you mentioned something earlier.
Well, you can do it with LotusScript. LotusScript has a DXL parser. There are several classes documented inside of LotusScript. Likewise, you can do it with Java. We at GBS have developed our own general utility, which I don't think we've made available on OpenNTF at this particular point. So you can do that. The other option is you can write XSLT, so or XPath queries to actually take the DXL and generate a report. So this is sort of a semi-non-programming way. Get a book on XSLT. Domino Designer has the ability for you to run XSLT against any Notes application, and it will generate the results and save it to disk. I've done that myself, and it does work. So that is certainly one option if you don't want to use the LotusScript or Java classes to process the DXL yourself, is to go that particular path. Another option that we use here at GBS is we use a Java package called EMF to pass the code inside the applications, but that's way more sophisticated, certainly not recommended for beginners, and certainly not if you haven't already got some exposure to Java programming.
Okay, one of the other questions is, does GBS offer services to assist with RAT? I think the answer to that would probably be yes, as in our consulting division, but
yes, that's not my primary role, but I'm sure somebody at GBS is more than willing to have a conversation with anyone out there that wants some assistance in setting up this sort of infrastructure, because part of the, for those of you who are not familiar with the product that I'm working on, it's a product called Transformer, and basically it's a service that we offer to organizations to migrate applications from Notes Classic to XPages. So what we have to potentially do is come up with an approach for testing any application that exists, the 10 million odd 10 to 20 million Notes applications that are out there. We have to come up with a way that we could potentially, we don't know which of those 10 million, 20 million we're going to be getting. So we've certainly developed an awful lot of expertise centered around this particular topic, and I'm sure we'd be more than willing to pass on some of that knowledge to your organization if there is an interest. But I'm not the person to speak to about that. But I'm sure Dawn or myself could put you in contact with the appropriate person for that.
Yeah, if anyone is interested in GBS helping them with any consulting, whether it be development, testing, or anything else, there should be an email address on your screen, info@gbs.com. Just shoot us an email, help you in any way we can. Always happy to help. I'm going to take one more question because I know we're running a little bit over in time. The last question that I have here is, which methodologies work best with RAT? And I'm not quite sure I understand that question, but hopefully, Peter, you do.
Okay. Which methodologies work best? Either, and the reason why I covered application development is, first and foremost, probably my estimate is 80% of Notes applications are developed using that methodology. So RAD and RAT work together exceptionally well. We use Agile and Scrum, and RAT will work, but it does require some modifications to the process. If you want to contact me to share if you're using Agile methodology out there and you want to share any experiences, then contact me via email, and I can deal with that more specifically. Where RAT does not work particularly well is the traditional waterfall methodologies. The traditional waterfall methodologies normally dictate that you write a formal test plan to test the entire application, and it's done at a particular point in time, and then it's executed in its entirety. Those methodologies do not particularly lend themselves to rapid application testing. So thank you, everyone, for some excellent questions.
And that concludes this edition of Group Talk. Thanks for watching. To engage in conversations with us, visit twitter.com/gbsnotes. To stay up to date, like us on Facebook at facebook.com/joingbs. And to watch entertaining and informative videos, visit youtube.com/gbsnotes. And don't forget, visit our website and send us an email at gbs.com and info@gbs.com. Thanks again.